Hello everyone, welcome to Grade Up. Today we are going to start graph theory. Till now we have completed proposition logic, combinatorics and set theory. Now we are starting graph theory. So graph theory is very important for GATE examination as well for interview point of view, because lots of question are asked based on graph theory. You have to prove something. When you go for in an IIT for an interview, there are lots of questions come from graph theory, linear algebras and probabilities. So you need to prepare them for interview purpose also. Okay, so let's start. What is a graph? So graph is a set of vertices and edges. Graph is a set of vertices and edges where V is a non-empty set of vertices. Set of vertices should be non-empty. E is the set of edges. What is directed graph? In directed graph, for example, this one. So here, if you see in this graph, there will be an directed edge, this one, and so every edge is in some ordered pair. Every edge is in ordered pair. I will write this edge as A comma B. That means it is starting from A and ending at B. So it is in ordered pair. And what is undirected graph? So V is the set of vertices, but E is different from directed graph and undirected graph. In undirected graphs, set of edges such that every edge is a set of two elements. Okay, so it is saying every edge is a set of two elements. So in set we have also read that order does not matter. So if I am writing A comma B, it doesn't matter. It does not saying that it is starting from A and ending from B. No, in set order of element does not matter. Where order matter? In an ordered pair. When we write ordered pair, at that time order matter. In a set, order does not matter. So whether I write like this or I write like this, it is both are same. So how will you draw an undirected graph? Simply draw the edges without any direction. Draw the edges without any direction. What is simple graph? In simple graph there is no self loop. So here it is also an example of simple graph, and there is no parallel edges. So what do you mean by self loop? Suppose there is an edge like that, then it is called, this is the self loop. What is parallel edges? So if there is more such edges like that, A to B, then it is called known as the parallel edges. Okay, but in a simple graph, these two, self loop and parallel edges, are not present. Where they are present? In multigraph. Multigraph can have self loop as well as parallel edges, and whatever we are going to study from here are going to study for simple graph. So remember that. Okay, we are going to study things for simple graph. And okay, so understand these terminology once, and then we can start the real problems. Handshaking lemma. So there is a handshaking lemma. What it says that in undirected graph, which graph? Undirected graph, sum of the degree of all vertices is equal to the twice the edges. So it is saying that sum of all degree of vertices. First, what is degree? The edges. Suppose we draw this graph. Okay, let's draw it again here. So we draw this graph. So what is the degree? The edges incident on that vertex. Edges incident on that vertex. So this will be one edge and two edge. So its degree is 2. Similarly, its degree is 2 because 2 edges incident on that vertex. Its degree is also 2 because 2 edges incident on that vertex. So 2 edges. Okay. So sum of degree of all vertices is equal to twice the edges. How can you prove that? It is written here. It is very intuitive. Try to prove why it is so. Sum of all degree of all the vertices is equal to twice the edges. Suppose I draw a graph. I draw one graph like this. Now I am saying its degree. What is degree? 2. What is degree? 3. What is degree? 3 because 3 edges incident on that vertex. What is degree? 2. Okay, now take the sum of all these. So 4 and 6, 10. sum is equal to 10. Now that should be twice the edges. How many edges? 1, 2, 3, 4, 5. 2 into 5. But this is not a proof. You need to think something intuitively. If you see any edge, suppose this edge, so this edge contribute twice. This edge contributing twice. How it is contributing? It is contributing in this vertex, in the degree of that vertex, and in the degree of that vertex. So every edge is contributing 2 times for 2 degree, 2 vertex, 2 different vertex. So it is, this edge is contributing a degree to that vertex, and this edge is contributing a degree to that vertex. So that is why sum of all degrees is equal to the twice of the edges, because every edge is contributing 2 times. In an undirected graph, the number of odd degree vertices is even. So here something is given which is actually based on that. So you need to understand it and also try to prove it. In an undirected graph, the number of odd degree vertices is even. So it is saying that number of odd degree vertices is even. How can you prove that? So we know that sum of all degree is equal to 2 into e, and here are some vertices whose degree is even. Whose degree is even? Okay, degree even. Degree even. There are some vertices. This, okay, and suppose there are such, whatever be the sum, you do it. Okay, sum of such degree, sum of such vertex whose degree is even, you can do it. And now sum of such vertex whose degree is odd, sum of degree of all odd vertices, odd vertices. Now you do the subtraction of, take it this as here. So what will you get? 2e minus में an even number. This will be the even number because you are doing the summation of degree of all the even vertices. This number will be even. When you do this subtraction, you will get an even number. Okay. Now these here, all the vertices having odd degree. All the vertices having odd degree. How can the sum be even? How can the sum be even? The only possibility is that the sum gonna be even when you have even number of odd degree. Even number of odd degree. That is what it is saying. Odd degree vertices is even. Odd degree vertices is even. Okay. So in graph theory, whatever the statement is written, you need to try to find some intuitive proof of it, not the detailed proof of it, so that you can remember it. Okay. In this way, you are going to use it again and again, that thing. Now we will be seeing some spatial graph. So first graph one is empty graph. In empty graph, the number of edges is 0. Suppose I draw here. This is an empty graph. Okay. Because there will be no edge. And you can draw with any vertices. There is no edge. Okay. So this is also an empty graph. This is also an empty graph. Now we will be seeing cyclic graph. So in cyclic graph, there is some kind of cycle. This cycle. Okay. And also in cyclic graph Cn, okay, it is representing like this. And what is that? It is the cardinality of edges. So in cyclic graph, how many edges we will be having? N edges if it is Cn. So this is C3. How it is C3? Because it is having 3 vertices and the number of edges it will be having 3. This is C4. How number of edges it will be having? 4. So in cyclic graph, you will be saying there is some cycle. There is some cycle. This is C3, C4, this is C5. There is some cycle. Okay. Now this is what is odd cycle, because we have 3 vertices and this is 4 cycle, even cycle. Okay. Odd cycle and even cycle. Now K regular graph. K regular graph where every vertex has degree K. I ask you a question, whether cyclic graph is also a K regular graph? Because see, what is the degree of vertex here? Degree of vertex. Here degree of vertex is 2, 2 and here is also 2. Because the number of edges incident on that vertex is 2. Here also 2, 2 and 2. Here also 2 and 2. So in cyclic graph, every vertex will be having degree 2. And this K regular graph, every vertex have same degree K. So in cyclic graph, the k is equal to 2. In cyclic graph where every vertex has 2 degrees, so it is known as 2 regular graph also. Can you also give another example of k regular graph? Think yourself. Try to think yourself to give an example of another graph such that every vertex is having same degree. So I am going to take an example, cubic graph. Cubic graph. In cubic graph, 1 1 1 1. Let me draw it first. Here try to find the degree of every vertices. See here 1 2 3 3 1 2 and 3 1 2 and 3 1 2 and 3 3 3 3 3. So here every vertex is having degree 3. Okay, every vertex is having degree 3. Can you find the number of edges in this graph? Can you find the number of edges in this graph? Till now whatever you have studied is sufficient to answer that question. Can you find the number of edges in this graph? I told you one handshaking lemma. So what is that? Sum of degree of all the vertices. How many edges vertices are there? 8. 8 into 3 is equal to 2 into E. And we will get E is equal to 12. Okay. So question will be very easy, but you need to understand the problem very well. Okay. Now we will be seeing complete graph. So in complete graph, there is an edge between, for all u comma b, v belong to vertex v, there is an edge between them. So any vertex you pick, suppose I pick and this, there will be an edge. I pick this and this, obviously there is an edge. You pick any vertex, any pair of vertices, there will be edge here. So that is in complete graph. So this is k1. There is only one vertex, so how can there will not be announced any self loop, because we are going to study this thing for simple graph. K2, in K2 we will be having an edge. K3, every vertex have an edge to other vertex. Okay, so these are the few examples, K5 and K6. See them and you will understand what is complete graph. Now I am asking you a question, number of edges in complete graph. How can you find the number of edges in a complete graph? So suppose this graph, this vertex, at how many vertices it will be connected? N minus 1. Okay, because there will be n vertices in a graph and I am asking that this vertex will be connected to n minus 1 vertices. Okay, and how many such vertices are there? So I am counting the degree. I am counting the degree of every vertices. What is the degree of that vertex? N minus 1. What is the degree of that vertex? N minus 1. What is the degree of that vertex? N minus 1. What is the degree of that vertex? N minus 1. N minus 1 how many times? N times. That will be equal to 2 into E. And we get number of edges as n into n by minus 1 by 2 here. So you are seeing that how to finding the number of edges is very you will, if you learn this handshaking lemma very properly, then it is very easy for you to find the number of edges. Okay, and solve some problem based on that, so that it is strike how to get the number of edges. Now bipartite graph. Okay, in how many way we can form the, so see first this statement. I told you the number of edges in complete graph is this. Also you can understand this by a different way. How? Read this. In how many way we can form the committee of two teacher among k teacher. Okay, so you have k teacher and you are asked to form the committee of two teacher among them. How many way you can do? So it is like that problem of selecting two people from a set of k people. How many way you can do it? KC2. So that is the answer. KC2, and that is also equal to k into k minus 1 upon 2. That if you place k is equal to n, then you will get the number of edges in a complete graph. Either think like this way or prove it using handshaking lemma. Both are correct. Now bipartite graph. In bipartite graph, what we do that we partition the set of vertices into two such that there will be no edge between one partition and one partition can have a edge to other partition only. For example, suppose I partitioning them, these two I partition and these two I partition. So these is my partition 1, and this is partition 2, this is partition 2. So this is partition 1, this is partition 2, and there will be no edge between these two vertices, there will be no edge among these three. So that is what is mean. There will be no edge in a partition. You can have an edge to other partition, that is allowed. That is allowed. You can have an edge to other partition, that is allowed. Actually, graph has lot of application in real life also. Okay. So how can this have? For example, the social networking sites, they may use it as that, like this is a set of couple, so it is a set of boys, it is a set of girls, then it will, the ages will represent they are the couples. So these kind of applications can be possible. Okay, but if you look at this, these are complete bipotatic graph. These are complete bipotatic graph. Why they are complete bipotatic graph? Because this vertex is allowed to have an edge between other partition, or you can say the other team. It is allowed to have an edge between other team. Now how many elements are there in other team? 3, and it is having an edge to all these 3 elements. Similarly this element, similarly this element, this element, this element. When this is true for every element, then it will become bipotatic graph. I asked you a question, can you find the number of edges in a bipotatic graph? Number of edges in a bipotatic graph. Suppose M is here one set, in there will be M, and here will be N, and I asked you the maximum number of edges present in this graph. When maximum will be present, it will become complete bipotatic graph, and I am asking what is the number of such edges. So in how many way it is connected? N. Okay. Similarly this, it has to be connected to all these N. Okay. It has to be connected to all these N. So we will be getting M times into N. Why am I not counting for this one? Because it is already counting. It will be a undirected edge. It will be a undirected edge. Okay. We will be learning this for undirected edge. Undirected graph. Now we will see a question on bipotatic graph. It is an interesting question. Try to solve it. A bipotatic graph has 10 vertices. Then maximum number of edges it can have. So a bipotatic graph is having 10 vertices. Actually, how we are writing the bipotatic graph? B, M, N, where M is the number of vertices in a set. Okay, this set is having M vertices. N is the number of vertices in this set. And now we can have allowed to have an edge like this. Okay. Now we are giving the total N vertex. It is not saying that how many are in this set and in this set. It is saying that M plus N is equal to 10, and we are asked to find the maximum number of edges can have. Okay, so we will try to understand the problem. Suppose if in this set we have only one vertex, and in this set I am having 9 vertex, so how many edges can I have? This can connect to this, all the 9, and I can have only 9 edges. 9 edges. Suppose if I increase it 1 and 2, and here we will be having 8, then this can have 8 and this can have 8. So 8 into 2 is equal to 16 edges. Okay. Are you understanding the problem? Here we got 9 edges, here we got 16 edges. So I need to find such a way that I get the maximum edges. So how can we can do this? So in our 12th we have a topic finding the maxima and minima. So it is that problem. How it is that problem? So suppose let this set has having k vertices, and this will be having n minus k vertices. I am taking n generally. We will replace it by 10 later. We need to find what will be the maximum number of edges. I told you here that will be m into n, and it will be k into n minus k. So that will be the maximum number of edges. Now differentiate it with respect to k. differentiate this with respect to k, and what we do to find the maxima or minima, we put it is equal to 0, and whatever we point get, we check whether it is a maxima or minima, and then we can find the value at that point. So I did the same thing here. I find at what position I can get the maxima or minima. It is k is equal to mid 2. Now checking whether it will be maxima or minima, we need to do the differentiation second time. I am not doing here because I know it will be the maxima. You can try it yourself and find it. Okay. So here we get k is equal to n by 2. Now what is n here? 10. Okay, so k is equal to 5. Now the maximum number of edges can be 5 here, 5 here. So this will be having 5, this will be having 5. 5 into 5, 25 edges we can have. This is the maximum number you can get with 10 vertices. Okay. Now see this gate problem that is asked in 2001. How many undirected graph not necessarily connected can be constructed out of these sets. So we will be having n vertices, and it is asking that how many undirected graph I can draw or I can construct, and it need not to be necessarily connected. So how can you do that? Suppose this. There are n vertices, and I am asking you how many possible undirected graph can be constructed. So how can you do that? How do you understand the problem? First, try to understand the problem first. Only then try to solve it. If you are not understanding the problem, try to read the question 1, 2 and make your speed fast. You should read the question very fast, but don't miss any point also. Okay. If you are missing some point, then what you do? Read slow and try to read 2 to 3 times so that you cannot miss any point. So it is asking that number of graphs can be constructed. So see here, if I make an edge here, this will be one possibility of graph. If I make this edge as well as this edge, then there will be one graph, and it is named. They are labeled. Okay, and we need to find the graph can be constructed. So okay, I will be having with n vertices, how many edges I can have? The maximum edges can I have? So maximum edges is present in the complete graph. So in complete graph, there will be n into n minus 1 by 2 edges are there, and we have proved it by two times. How? By using handshaking lemma and by using some intuition also. So these many edges can be present in a complete graph, and to construct a graph, an edge may or may not be present. This may affect it. Similarly, this edge may or may not be present, this edge may or may not be present. So that means if I choose this edge or not, it makes a different graph. If it is present, then it is affecting. So for every edge, how many options I will be having? 2 options. How 2 options are there? It may be present or it may not be present. And how many edges we will be having? These many edges. So the answer will be 2 power this. So that much graph we can construct with n vertices which are labeled. Okay. So the right option is D option. See this question asked in GATE 2017. Read the question properly before attempting you. Okay. G is an undirected graph with n vertices and 25 edges such that each vertex of G has degree at least 3. Okay. So they are saying that every vertex have degree at least 3. Then it is asking then the maximum possible value of n. What is n? The vertices. So we are given n. We are given edges E is equal to 25. And we are given that every vertex has degree at least 3. Degree at least 3. At least 3. Okay. Now how will you solve it? How will you solve it? See this. If I give E to each, let M be the minimum degree. M be the minimum degree and capital M be the maximum degree of a graph. If I assign the minimum degree to each vertex, I assign the minimum degree to each vertex, suppose what will happen that m into v, and that will be less than or equal to 2 into e. That will be less than or equal to 2 into e. Why it will be less than? Because I am doing some kind of approximation. For that I assign the minimum value to every vertex. I will get this. So I will get m is less than or equal to 2 into e upon my v. Similarly, what if I assign the maximum m? Then it will be less than m. Okay, less than m. So it is what it is written here. This is what it is written here. Now what is m? M is equal to 3, the minimum degree, because at least every vertex should have degree 3. And the question is asking maximum possible value of n. So n can vary, but it should be maximum. Okay. E is equal to 25. So when you put E is equal to 25 here, it will become 50 upon V, which is we need to find. So do the cross multiplication here. We get this 50 upon 3, that we get this. And but we cannot have a vertex in fraction. You cannot, vertex should be complete or not. So we get V is equal to 16. Why not V is equal to 17? That cannot be possible, because it should be less than or equal to 50 by 3. Okay. So V is equal to 16 is the right answer. That is the maximum possible value of n. Okay. So that's all. We will be seeing in our in another lectures about connectivity. Okay. So till then, try to practice a lot, and problems in graph is very interesting. You will enjoy if you try to prove them. And once you prove 2-3 problems, you will gain confidence, and it will become very interesting topic. Graph theory is very interesting. Okay. So try to practice them. Thank you.